See, now you see in this particular problem is a PYQ problem, previous year question they have given. So, it is mentioned that the submitted class B network has following broadcast address. So, in this problem, it is mentioned that it is a broadcast address. So, it is class B. So, whatever the value if you have written is nothing but what 144.16.95.255. It is mentioned that it is class B. So, for a class B, network bits are how many? 16 bits. So, from here to here, these all are network bits because it is given class B. And it is also mentioned that it is the broadcast address. So, in this leftover bits, okay, the broadcast bits will be there. So, for a broadcasting, the host bit should be continuous ones. But how many ones will be there? So, that will be depend on the host bits. So, network, subnet and the host bits will be decided from the mask. So, that is given in the options. So, you have to start solving from the options and then find out whether it is suitable value or not. So, here this 95.255 I can write like this. It is 0, 1, 0 and then followed by what? 5 ones. You can say 64, okay, plus 31, it becomes 95. And here you have 255, this 255 I can write like this, 8 ones. So, it is a clear observation you had a continuous ones. And for a broadcast address, obviously host bits will be continuous ones. But here how many are the host bits? That can you know only after separating the subnet and the host bits. Then you can find out the leftover host bits. And that is available in the mask. So, that's why they have given in the options the mask values so that you can separate the network subnet and the host bits. So, now if you observe, so to have a clear idea, the same value once again we are writing so that you can cross check with every option. So, that I am writing here. So, you can say 0, 1, 0 followed by 5 ones and here you can have what 8 ones you can say. Okay, so once again we are writing the same value because there are 3 options now like that. So, let us check all the values. So, again it is given 5 ones and here you have what 8 ones. And here one more, okay, and for this value once again we are writing 0, 1, 0 for the third option, okay, 5 ones and again 8 ones. So, basically here what we are doing is the same value once again we are writing 3 times. So, now you check every option, separate the subnet and the host bits and those many host bits here ones are not, you verify. If those many host bits here it is ones are there, then that is going to become a for that concerned mask actually. So, you can observe in option A. So, if in the case of option A, if you have taken, so the mask is given as 255.225.224.0. So, further how you have to approach the problem, you can see it is given as class B. So, for a class B network bits are 16. So, from here to here these are the network bits. And here these values convert into binary. So, this 224 I can written as 3 ones followed by, okay, 5 zeros dot. This 0 I can written as 8 zeros. So, this is already network bits and these 3 bits are the subnet bits and remaining all are the host bits. Because normally for the mask, network subnet will be the ones and host bits will be zeros. So, you can see here the host bits are 5 plus 8, total 13 bits are there. So, for this particular mask, if that given value has to act as a DBA, host bit should be continuous. So, host bits are 5 plus 8, totally 13 ones should be there. So, you can check here from here to here, 13 continuous ones are available and this 0, 1, 0 is also subnet is possible. So, obviously here A is the one answer we can say, but is it necessarily the A means? That's why they have given B and C also. Let us check the remaining all options also, but here the A is satisfying you can see, okay. That means, is it a must that this is the only should be the answer? Means you have to check the other options also. If the required condition is satisfying, then those values also can be the answers. Okay. So now if you check option B, so this option B I can write like this. This is 255. Okay, dot 255 dot 240 dot 0. So these all are the network bits, and remaining all bits, because it is a class B that is given in the problem. So these bits, if I convert into binary, so it is 4 ones followed by what? 4 zeros. And this 0 I can write like this. It is 8 zeros. So following the previous procedure, you can say these all are the subnet bits. Remaining all are what? The host bits. So you can see 4 plus 8. Totally 12 bits are the host. So continuously 12 ones you expect for that value to become a DBA. So that's why once again I have written to avoid the confusion. So here you can see 4 plus and 8 all are continuous ones. And you can see before that the subnet is also possible. 0, 1, 0, 1. So here you can say B is also answer like that. B is also answer. So it is not necessarily the A. It can be B also now from the calculations you find out. Okay. Now suppose now if you go for, you have to check for the option C also. So they have given the mask is 255. Okay, 255 dot 248 dot 0. It is class B. So these all are network bits. So this 248.0. If I convert into binary, this 248 I can write like this. It is 5 ones followed by 3 zeros, and this 0 I can write like this. 8 zeros. So these 5 ones are subnet, remaining all are the host bits. So you can say 3 plus 8, how many? 11 continuous ones you expect. So you can observe from here to here, 11 continuous ones are there? Yes. So for this mask, that value is acting as the DBA. So that is also correct, and you can see this subnet is also possible. So this is also answer. So that is the reason for this particular question. See, could be any one of the all these three options. You can say it is asked in GATE 2006 actually. So what is the final answer? D is the answer, final answer you can say. D is the answer. That means it is some application based question based on the basic knowledge whatever you are going to develop in the networks. Like we know what is the basic input means. For the DBA of any network, if you want to broadcast on any network, okay, the host bit should be continuous ones. So that value where the host bits are continuous ones will not be given to any computer or a host. So that is a basic fundamental. Based on that, they have given this application question. So they are just testing whether the all possible, if any new IP is given, that combination is possible or not. Okay. See, basically this model problem is to talk about the window size. See, window size is such a parameter. You will take a sequence numbers. Okay. On the top of sequence number, you will place one window size, and that window size will tell you at a time, in a round trip time, how many frames you can transmit. Okay, that is the meaning of window size. Because even the sequence numbers are there, how many frames at a time you can send will be decided by the window size. If you say you can send one by one, if you send only one, the utilization will be less, because once they have given a huge bandwidth to you, and if you are designing a protocol only for one frame, in the entire trip time, the entire channel will be wasted. See, you are calling as a channel whenever the bandwidth is divided into different channels. Okay, otherwise you can call it as the bandwidth utilization itself. The basic idea why the bandwidth will be divided into different channels, okay, so that the frequencies which are already provided in the bandwidth, they are properly utilized. the bandwidth is high or width is more, so that you can divide into different frequencies, and you can assign one frequency to one channel. That is the only difference. Like people will think the channel utilization and bandwidth utilization, it will be same if it is not divided. But when the bandwidth is divided into different channels, okay, you can transmit on one channel with a one frequency, other channel in another frequency, like that. Okay. Okay, you can maintain some gap also from one frequency to other frequency. If you want to maintain some gap not to be utilized, just acts like a guard band. Okay, to avoid distortions or mixing of the signals, like that you can do. So here that is the main reason of the window size. That is the first thing. Second thing is, sir, when we are using that word like window size is number of frames transmitted in RTT. So why you are taking the time of RTT? That is the second doubt, because when you send the data now, this data once it reaches to the destination, how does the sender knows that this data will go to destination? It's confirmed that it is reached. So definitely here the sender will be knowing whether it reached destination or not with the help of ACK only. So this unacknowledged data when you are sending will become acknowledged once the data is reached to receiver. So that's why you have to wait up to RTT. And second one is, normally in this window size calculations, why we don't take the transmission time means, when you are designing a protocol, you should design the protocol normally for the channel, because to that channel only or the cable only the systems are connected. If you say I will design a protocol only for a single system so that I will include TT, so is it not you have to design for every stations? Like in the bus topology, if your 100 stations are connecting, for all 100 computers, will you design separate protocols? You have to design only for the channel. So that's why you will take only what you can say that the bandwidth into criteria, but not the TT. Yeah, when you go for a utilization of a particular system, then you can say link utilization of some system. When they say, then you had a denominator term of TT plus 2 into PT. So this gives a clarity. Whatever the window size you want to calculate, that depends on the bandwidth, and you wait until the RTT time, so that you will get the number of bits, and if you divide by the size of the unit what you send, so the number of frames you can get. It is so simple. So that for the entire channel or the entire cable, you can utilize. Okay. Now see, based on that, the simple question they have given, you can say station A uses 32 bytes packet. So I can say, you can observe here, the data size they have given in this problem, the unit size is 32 bytes. Means one single unit is 32 bytes. So when you are transmitting this single byte during transmission, you will call it as a unacknowledged. But once you get the ACK for it, it becomes a acknowledged. And here you see the round trip time between A and B, RTT, is given as 80 milliseconds. 80 milliseconds. Practically, this RTT you can calculate using some timestamp option also, but they have given. And the bottleneck bandwidth, that's the maximum bandwidth, is given. The capacity of the bandwidth is given as 128 kilobits per second. And see, in some problems, you will find a word like a data rate of a sender will be some number. So actually they have to utilize that bandwidth. Now why they have given data rate means, actually whatever the rate at which the sender is sending, obviously at most it should be a bandwidth, or it will be less than the bandwidth. Why it will be less than the bandwidth means, because of different parameters has to be there. Noise will be there, some losses will be there, based on signal strength, different factors will be there. That's why normally the throughput or the rate at which you send will be less than or equal to bandwidth. So when the bandwidth is not given in the problems, when they have given the throughput or data rate, you can take it. So now say what is the optimal window size that A should send. It is so simple now. So how to do the calculations? See, this bandwidth I can write like this: 1 second is 128. into K means what? Kilo means what? 10 power 3 bits you can say. And here RTT means what? Round trip time RTT is given as 80 milliseconds you can say, 80 milliseconds. So, for 1 second these many bits in this RTT, how many bits can fill that particular channel means if this will be cross multiplying. So, 80 into milli means what? 10 power minus 3 into 128 into 10 power 3. What are the units here? Bits. So, these both will cancel now. Okay, like so this is nothing but what? 80 into 128. So, what are the units here? Bits you can say, bits. So, whatever you calculated is nothing but what? Number of, okay, number of bits that are can be accommodated in the transmitted in the RTT. But you can say window size na, okay, you are sending the frames you can say. So, now window size is nothing but what? Number of frames that can be transmitted. Number of frames that can be transmitted in RTT is total bits by the frame size. Total, okay, bits by frame size. So, total bits how much? 80 into 128. These many bits divided by the frame size given as 32 bytes now. So, 32 into 8. Why into 8 means? Because they are giving in the bytes, convert into bits. Because the numerator is in the bits you can see. So, if you do the calculations, this is how much? 8 how many times? Okay, 16. Okay. So, 16 how many times? It is 2. So, this how many times? 40. So, 40 frames you can send. Okay, like that. This is how you have to solve the problem. Answer is what? 40. But you say, sir, after that, if you want to, sir, if they ask a question for number of sequence, very simple. 40 is not a power of 2. Take it a power of 2 and you design. But as per this problem, 40 is the answer. Okay, like that. So, this is how you have to analyze. Okay. So, this question is a type of application question also. You can say the basic fundamental is whenever a packet is coming to a router, the packet destination IP will performed bitwise and with the mask of interface. If you get the subnet ID matching with that interface ID, then you will forward by that router on the next hop. But here this problem is to convey that they will get a more than one answer. So, when you get a more than one answer, you have to go for the longest prefix matching. Why it is so? Because when the router has forward to next hop, then in the next router also out of many paths, one path you are going to choose. So, here this subnet mask and that subnet mask also, the both subnet IDs will be same. Then out of these two, which one I have to choose means the extreme value, because there exactly the computers are present at the end. And the computers where they are present, it will be number of computers will be less compared to as a group. And that is where exactly the routing has been done. So, the longest mask matching is giving you some an idea that when a packet come to your router and if you find more than one path, then the path which is having more number of ones in the mask is preferred. Now, see, based on that, if you try to analyze, see, they have given some IP address in this problem. Yeah, this is one of the previous PYQ questions of the GATE. Say an IP router implementing CIDR, classless addressing. The router's routing table has the following entries you can see. So, basically just now we have given an idea, na? The IP address how much? 131.23 and here 151, okay, 76. So, this is the IP address that is given in the problem. See, the router's routing table has the following entries. So, it is having this particular the table. So, normally if it is a class full, na, the table size width is going to increase. But since it is a classless, little bit the width is decreased. The reason is, you can see that mask is also joined along with that subnet ID. If it is a class full, this mask will be shown as separately. So the width of the table is going to increase. Okay. So now you can see if I take the first entry, so that value is /12. It is given as /12. So this is the mask. So what is the meaning of /12? Means what? Continuously 12 ones will be there, followed by 20 zeros is the mask meaning. So where the meaning of 12, if I convert into the decimal, so I can write like this. This is nothing but what? 255, already 8, and here 4 na, so it is 240.0.0. So this is the inner meaning of /12. How do you got that? Means what? /12 means what? Here is a 255 na, 8 continuous ones followed by 4 more ones means 240. So between these two, if I perform bitwise AND, this value is how much? 131, and this is 0, and this is also what? 0. If you observe the second row, it is 23 and 240. Okay, this 240 I can write like this, 4 ones followed by what? 4 zeros. This 23 I can write 0, 0, okay, 0, 1, 0, and 3 ones, means 16 plus 7, 23. So if I convert into binary, so 0, 0, 0, 1 followed by 4 zeros. And this value is how much? Okay, it is like this. So 16, na? 16. Okay, so you got 16. So you can simply substitute here 16. Now you see, whatever the subnet ID you have calculated, it is matching with the subnet ID that is given. So since it is matching, so via this interface 3, the packet is forwarded. So here you got an answer that via this interface 3, the packet is forwarded. So that router will perform bitwise and not only with this interface, the destination IP whatever you got, that will be performed bitwise and with the second interface also. You can see what is the destination IP? 131, okay, 23.151.76. Okay. What is the mask of this particular second interface? So that is how much? /14. So /14, if I convert into binary, it is 255, already 8 ones, plus 6 ones means this value is 252.0.0. So if I perform bitwise AND, so this is 131, it is 0.0 you can say. Okay, like this. So it is 23, okay, and 252 you can say, 23 and 252. So if this 23, if I write here, I can write 0, 0, okay, 0, 1, 16 plus 3, it is 23. 252 means what? Here I can write what? 6 ones followed by 00. So this is nothing but 3 zeros, 1, 0, 1, 00. So 16 plus 4, how much is the value? 20, it is 20. But is it matching with this second entry? No, you can see it is 28, it is 20, it is mismatching. So it is a cross mark, means it is not matching, so it is cross mark. Same like that, if you take the third interface, so who will do this calculations means what? That router, when the packet coming to the router, it will perform bitwise and with every interface. Now, if you talk about this third interface, that destination IP is given as 131.23.151.76. So what is the mask value? You can see it is 16. So 16 I can written as 255.255.0.0. So if I perform bitwise AND, this value is what? 131, it is 23, 0.0. Okay, but here you can observe that it is 19.0.0. It is mismatching. This gives an idea that two interface also should not be forwarded. Okay, like that. Now if you go for the fourth row, so the destination IP is 131.23.151.76. So what is the mask of this fourth row? You can see it is /15. So this /15, if I convert into binary, this value is 255. Already 8 ones followed by 7. 7 means what? It is 254 0.0. So between these two, if I perform bitwise AND, this value is 131 and it is 0.0, you can see. 0.0. Okay, like this. And what about this particular value? This is 23 and it is what? 254. So this 23 I can write now as 3 zeros and 1. 16 plus 7, it is 0 followed by 3 ones. This 254 I can write like this. Okay, 7 ones and 0. So this is nothing but what? 3 zeros, 1 0, 1 1 0. It is 16 plus 6. How much? It is 22. So you can substitute here 22. So you can see that number, is it matching with this interface ID? Absolutely yes. So now you can forward via interface 2. So finally, after doing all the calculations, you got two answers. See, the first one you got and the ending one. But out of these two, what is the final answer means? Just now I have told you the longest mask matching or a longest prefix matching. So whenever a packet comes to a router, if you find more than one path, then the path which is having more number of ones in the mask is preferred. You can see here the mask is 12, but here the mask is 15. So more number of ones is here. So what is the final answer? You can say this one is the final answer. Which interface? Interface 1. So via interface 1, the data will be forwarded finally. So this is the answer for this final answer. Because there exactly the computers are going to be present. Okay, so this is one more model you can see.